Yes.
Yes. Good.
Perfect.
Yes.
ಸ್ವಲ್ಪ ಕ್ಲೋಸ್ ಮಾಡಿ ಸರ್. ಮಾಡೇ ಬಿಡಿ, ಚಳಿ ಇದೆಲ್ಲ. Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So there are 31 participants from 23 different disciplines. So really a very heterogeneous group. Usually in this type of courses, I used to talk about the poverty, inequality, developments, and sustainable issues, energy issues, environmental issues, like that. But this time, many of the previous batch students have requested to talk about research techniques, whether it's maybe social sciences like economics, commerce, management, political science, social work, and even for the history and political science, and even for law, even for physics, even for chemistry. We need certain amount of understanding of data. So by understanding the data, we can make our research skills more powerful, so that we can present the data in a very meaningful. That is one thing. And each of the data has its own characteristics, nature, scale, and many things. And when we do research, always research is a kind of proof providing process. You all know, as I have understood from the administration, this HRDC, around 20 of you have completed your PhD. 20 participants have completed PhD, and 11 are yet to complete their PhD. So that, so I thought of discussing some of the things. It is not presentation, it is the discussing some of the things. So there are science people also there, like physics, chemistry also there. Even for chemistry, physics, they do conduct a lot of research, even in the lab. But though they are conducting research in lab, they have to test and tell what is the validated result, all those things. So in each of the research area, there is a need of understanding the basic requirements of the research methodology. So for that, I have chosen this topic. Today, I will discuss some of the issues related to data distributions and techniques. Let me start with the basic idea of research. The basic idea of research, as we all know, research is not only providing the new things, even though re-putting the existing thing, redefining the existing thing with evidences. So without evidences, the research will not be of any use. There is no validation for our research if you have not given the sufficient proof for our arguments. So whether you say there is a difference, whether you say, so there is an increase, or there is a decrease, whatever you say, there is a relationship, there is an impact, there is an association. Yes, even for the law, some of the law influences the citizens' attitudes. Then how can you say the law influences their citizens' attitudes, becoming more serious about the practicing the fundamental duties? How could we say, yes, the law is powerful of influence? So for each and everything, you have to give a proof. Without giving proof, if you say anything, it is of no use. It's of no use, because in each of the research, it is not only simply providing information. It is providing, it is giving insights in that information. So we have a lot of informations. Nowadays, we have a lot of informations and a lot of data also we can get. But just providing information, anybody can. So even in the research, even in the newspapers, we get information. It is not that giving information. Research is giving insights in that data. insights in that information. So giving insight is not sufficient. So what are all the insights you give for each of the insights? For each of the insight in the form of argument, in the form of inferences, in the form of statement, in the form of any hypothetical issues, you have to provide sufficient data support for that. Okay. So without providing sufficient proof, your argument will not be sustained. So therefore, research is not simply searching for the new things. It is the in the great understanding. It is the providing a proof for the our arguments or the disarguments. So there are two ways of providing the proof for your arguments. One is you provide the proof from the help of your previous research works. So we are just entered in the line of the research and we are doing research, and there are many people have already done a lot of research in your area, whether it is maybe economics or commerce. So there is a history for each of the research. Okay, from the history of the research, from the previous research work, you can take the incidences, you can take the proved arguments from the previous research work, and you can support your argument. That is one thing. And this is always, as you know, it's a theoretical frame for your methodology, for your stating the hypothesis, for developing, setting the stage for your research or your subject matter of your interest. For everything, you take the proof from your previous research work. When you start doing research and saying something out of the empirical data, whatever you have. So you have some data. So you have some empirical evidences. So when you have empirical evidences and these evidences are not sufficient to support your argument, that's very, very important. So what are all the evidences or the data you have? The data or evidences are not sufficient to support your argument. If you really want to support your argument, you have to provide the tested proof. That's very, very important. So the data has to be tested. The data has to be tested. What are all the data you have? That has to be tested. What are all the evidences you have? You have to test them. And then you say, yes, I have sufficient proof for my argument. For example, there's an inverse relationship between the income and consumption expense. There is a positive relationship between income and consumption expenditure. Then you all know there is an inverse relationship between a price and the demand. Whenever the price increases, the demand increases. So there is a positive relationship between the number of hours you study and the marks you obtain. So like that, there are many things, many arguments we can do. Okay, and very, very simple way, my mother cooks very good sambar. How can you say? My mother cooks very good sambar, my mother cooks very good bisibale bath, a very good wangi bath. If you say like that, so what is the proof you have? The proof is that you have tested that. You have tasted and you have tested. Both. You have tasted the wangi bath made by your mother and you have given the result that yes, the wangi bath made by mother, cooked by mother, it's really good, very tasty, so that I always say my mother is a good cook. So like that, what are all the arguments you make? You have to give the tested proof. So research is providing tested proof for your argument, your statements, your inferences. So therefore, understanding the data is very, very important. So what to understand? So what are the sources of data? What are the types of data? What are the properties of data? Or the scale of data. The most important thing is the scale of data. So the data, whatever the data, whether it's maybe science or arts or commerce, management, even in one of my best colleague has did his Canada research work by using the survey method. So he has conducted the survey and raised the opinion, and then he has written the thesis with lot of tools and techniques, even in Canada. So this is how we have tried in many places. They suggest you always support your argument with the field data. So therefore, there's always scope for validating your data, providing empirical insights or empirical proof for your arguments. So data is not a problem. So nowadays we talk about data analytics, data mining, data digging, and data manipulations, processing, many things we have. So, but understanding the data will give you knowledge. But out of the data, how to make the decisions? So if you want to make the decisions, you have to follow many things. So as I already mentioned, the most important properties of the data is the level of data measurement. That is the scale of data. At what scale you are having the data? The data you have is of what scale? Is it a nominal scale data, ordinal scale data, interval data, ratio scale data? So you say anything, the data will be treated as the nominal, ordinal, interval, and ratio scale data. Nominal data is the lowest level of measurement, and the ratio scale data is the highest level of measurement. And most of the times we also use ordinal and interval, but in the research, we rarely use this ordinal and interval scale data, and we largely use nominal data and ratio scale data. Just for understanding the nominal data, let me talk about, so nominal data are the numbers are used to classify or categorize. Whenever you think of categorizing some, like male and female, urban, rural, literate, illiterate, good and bad. So whenever you want to separate or classify the data into different sections, then you assign some numbers just to understand. 1 means male, 2 means female, 1 means urban, 2 means semi-urban, 3 means rural, 1 is good, 2 is bad. Like that, you assign some numbers just to classify the data. And these numbers are having meaning. The numbers you have assigned, they are having meaning. Meaning is what? 1 means male, 2 means female, but the 1 is not having the value. It is only a number you are assigned, and there is no value for that one. Let me give some small example. 1 for male, 2 for female. I have told. If is 2 males are equal to 1 female? No, it is not possible. 2 males are not equal to 1 female, because the numbers you have given, they're just the numbers just to identify some attributes of your data or the characteristics. So therefore, there is no value for the numbers. So I have given some 1 for the educator, 2 for the construction workers, and 3 for manufacturing workers. How you have given these kind of the numbers? Why it is 1 for educators? You can give 1 for the manufacturing workers. You can give 2 for the educators. So you can give any number. The number doesn't give any value. Here, I also given the second example, like 1 for African American, and 2, 3, 4 for the Oriental Americans. So giving 1 that doesn't mean that African American is superior than the Anglo American or Hispanic American or Oriental American. No, it doesn't mean anything. So only just to identify some characteristics and to classify the group, you have given the numbers. Like that, the second category of data, that is the scale of data. It is the ordinal level data. Ordinal level data. Numbers are used to indicate rank or order. So like that, the president, some order is there. 1 is for representing president, and is also there is some order. President, vice president, plant manager, department supervisor, and employee, like that. So ranking productivity of employees, test ranking the 3 brands of the soft drinks, giving first rank for the Coca-Cola, second rank for the Pepsi, and third rank for the Sprite, like that. You can give rank. So you can give first rank to one teacher, second rank to another teacher, third rank to another teachers. So you are ranking. So you are putting in some order. You are assigning number, but these numbers are not just numbers. They are having a positional value. They are having a positional value. So positional value in the sense, if you say 1, he comes first. If you say 2, he comes next. So like that, there is a value for the number, the positional value, not the real value. Again, I'm telling you, there is no real value for the numbers. They only having the positional values. The other way like that, this is the good old story of tortoise and this, you know that who comes first, who comes next. So this is another example of given 1 for strongly agree, 2 for agree, 3 for neutral, and 4 for disagree, strongly disagree. Like that, we can also give numbers. But here, one thing is that you have to understand this very important, which is very important. In most of the commerce and management research works, they use these kind of the numbers, ordered numbers. These are known as ordered numbers because 1 represents strongly agree, 5 represents strongly disagree, 5 represents strongly disagree. So there is a scale called the Likert scale, Likert scales. So once you have used the Likert scale, the data has enumerated by using the Likert scale, meaning these numbers, because these ordered numbers becomes the ratio scale numbers. Purposefully they do that. Purposefully they do that. So once you have converted these ordinal numbers into the form of ratio scale, then you have lot of scope for using the higher order techniques. So that's why they convert the ordinal data into the ratio scale data just by saying Likert scale. So when you say Likert scale, you have to change this order. Here I have given 1 for strongly agree and 5 for strongly disagree. Now you need to change. Need to change in the sense, for strongly agree, you have to give strongly agree, you have to give 5. Agree, you have to give 4. Neutral 3, disagree. Again, it is 2, and the strongly disagree 1. You know, strongly agree will come first. Which is come first, you give 5, because I'm not talking about the order number, I'm talking about the ratio scale. So now you are converting order scale into your ratio scale. Then for strongly agree, you have to give 5. The highest value for the highest position. Okay, it's the number ratio scale number. It's not the order number. And then there are some data which are also available, like the interval level data. So the distance between consecutive integers are equal. The relative magnitude of numbers is meaningful. Differences between numbers are comparable. Location of origin 0 is arbitrary. For example, your Fahrenheit temperatures, like what is the BP, what is the share prices. So when you talk about the BP, you always say 90 by 130 and calendar time. So each and every, because from January 1st to 2021 to 2022, it's exactly 1 year, like that, and financial year. So from here to here, like that. So all these are having the interval type of the data, and most generally we convert this interval level data into the ratio scale data by taking the average. So for example, share price is 180. Then you divide these two numbers by 2, you will get 90. So just by dividing, we can also convert this interval data into the form of ratio scale data. The last type of the data is the ratio level data. So the ratio level data is the highest level of measurement data. So relative magnitude of numbers is meaningful. Differences between numbers are comparable. Location is origin, or location of origin is 0, is absolute, and natural numbers. They're all natural numbers. You can add, you can subtract, you can multiply, you can divide, you do anything. The ratio scale data is the most highest level of measurement data. You can use it for any purposes. For example, height, weight, and volume. Monetary variables such as the profit, loss, revenue, expenses, even your readings in the labs, like whatever all the tests you conduct, chemical test or the physics you can do test, you records the numbers, some numbers. All those numbers are the ratio scale numbers. Why I am imposing, giving more scope for the scale of data is, if you fail to understand the scale of data, if you fail to understand the scale of data, any techniques further you use, it may be wrong. It may be wrong. So therefore, the tests are the certain tests are meant for nominal data, certain tests are meant for ordinal data, certain tests are meant for ratio scale data. For the nominal data, you cannot use ratio scale tests. For the ratio scale, you cannot use the nominal scale techniques. So therefore, you have to be very serious about identifying the scale of the data. So then the question arises, is the data is sufficient for giving proof? Why I am asking this question is because whenever we do research, when we present the outcome of our research, we can make two types of the analysis. So one is descriptive type of analysis, and the second one is analytical type of analysis. This descriptive type of analysis presents the status of phenomena or what is what. Meaning, just you are explaining the status quo of the phenomena by using descriptive statistics like mean, deviation, correlation, even simple regression, index numbers. You can explain what is what. Okay, but you cannot argue out of that. The descriptive, under the descriptive analysis, there is no scope for making the arguments, drawing the inferences, or concluding something. It is because of this. There is no cause and effect kind of analysis. There is no relational analysis. There is no impact analysis under the descriptive analysis, because the scope of the descriptive analysis, it limits only to explain what is what. Whereas in the analytical analysis, it gives tested proof for your arguments. The analytical type of analysis, it gives tested proof for the arguments. Whatever you say, whether it is arguing something for right or wrong or anything, right? Whenever you want to prove something, whenever you want to infer something, you have to give proofs. So for giving proof, it is the inferential statistics. In statistics, we have two types of the techniques. One is descriptive techniques like mean, deviation, correlation, and inferential statistics. Under the inferential statistics, we have mean difference tests, relation tests, impact tests, processes, associations, and distributions. And it also includes, if somebody are there, I have seen economics, they could have been studied this econometrics. So the inferential statistics, it also includes, or the analytical analysis includes both inferential statistics as well as the econometric analysis. Econometrics, it's a test proof providing mechanism. So the econometrics, the meaning of econometrics itself is the science of measurement with valid proofs, okay, to provide the valid proof for the arguments. So therefore, both inferential statistics and the econometric analysis will help you to provide the proof for your analytical analysis. Wherever you want to prove something, you have to take the help of the inferential statistics, or you have to take the help of the econometric tools and techniques. And very interestingly, each of these tests like mean difference, relation test, impact test, whatever the inferential statistics and econometric tools and techniques I have told, each has many tests. And these are basis for formulation of hypothesis. Hypothesis meaning it's a tentative statement or an assumption. You can make it as an assumption. And whenever you try to make some assumptions or some statements, tentative statements, you should have this background. So once you have constructed the hypothesis, you have to test that. Hypothesis is generally, sorry, just a minute. So whenever you construct the hypothesis, you are going to prove something. You are going to argue something. So if you want to construct the hypothesis, you should know for what I am going to construct. I am going to construct to prove the mean difference. I am going to prove the mean difference. I am going to prove the relations, or I am going to prove the impacts. I am going to prove the processes. Is I am going to prove the association. Is I am going to prove the distributions or the skewness in the data. So for what I am going to constructing the hypothesis. You construct hypothesis only based on these things: difference, relations, impact, processes, associations, and distributions. Any hypothesis will be of this kind. And you also know, I'll come to that little later. Okay. Once you have understood your data, whether the data is nominal, ordinal, and ratio scale data, interval or ratio scale data. Here I am presenting both interval and ratio scale data in the single head because for the interval data, there are no analysis. You have to convert the interval data into ratio scale. That's very, very important. You have to convert your interval data into ratio scale. How to convert? If there is 10, lower limit is 0 to 10, then you divide that 0 plus 10 divided by 2, you will get 5. If the interval is 10 to 20, then you divide 10 plus 20 will be equal to 30 and divided by 2, that becomes 50. So that your interval like 0 to 10, 10 to 20, 20 to 30, 30 to 40 will become 5, 15, 25, 35, 45 like that. So that you have to convert your interval data into scale data to make it to make the presentation of the interval in a meaningful way. That's why I have put both interval data and the ratio scale data on the one hand. On the other hand, we have nominal data. I have already told that nominal data, it is a categorical data. It is not the ratio scale data or the ordinal data. It is only the numbers we have assigned to represent some characteristics or attributes of that category or that group. Okay, for example, 1 is for male and 2 is for female. How many males are there? How many females are there? If I say 25 males, so the 25 is the repeated number for the males. Okay, like that. So nominal number. Okay, and assumes that you have only one variable. So one variable, it may be a nominal variable, it may be an ordinal variable, it may be a interval or ratio scale variable. If it is a ratio scale variable like height of the otherwise any example you can take marks of the students. So because since you are all teachers, you should know marks of the students. So if the marks of the students, it's a single variable. Marks is a single variable. I'm talking about marks is the single variable. So if you have marks as a variable, marks, M-A-R-K-S, marks, you have assigned marks to students. So you have conducted a test for 20 marks and 60 students or 70 students in your class have scored from 0 to 20 because there is scope to score from 0 to 20 and they have scored. Right? They have scored. So when they have scored, if you want to know what is the average performance of the student, what is the average performance of the student, then what you do, you have to calculate the mean for that data. You have to calculate mean for the data. So, for example, for 20 marks, students have scored 12 as average. On an average, students have scored 12 marks. But that doesn't mean that all the 60, 70 students have scored 12. Some may be scored 5 marks, some may be scored 20 marks, some may be scored 3 marks, some may be scored 17, 15, 16, 12, 30, 10. Like that, they have scored differently. Meaning, there are randomness in that information. There is randomness in that information. There are dispersals in that data. So that dispersion in the data is known as how far these individual observations are scattered from the mean. That need to be understood, and that will be understood by standard deviations. So the mean represents the central value, and the standard deviation gives you how the individual observations have scattered. So that is dispersion. So there are two techniques. One is the central tendency, another one is dispersions. If you are having the ratio scale data like the marks under the descriptive statistics, it is very important. Under the descriptive statistics, you can compute mean and standard deviation. Okay, only that means the marks scored by the class is 12, the average marks scored by the class is 12. Assume that the deviation is of 3 marks. So then the deviation is 3. On an average, the central value is far from the individuals is 3 marks. So that's the only thing you can say. But how can this marks is compared with the complete school? Okay, in the school, the average marks may be different. In the school, the average marks may be different. The average marks in the school may be 15 or 16. 16 assumes that the average marks scored in the school, it's 16. Now, you want to know whether the marks scored by, it may be 15, assume that it's 15. The marks scored in this class, it is on par with the school or not. You want to know, Then how can you make these comparisons? You simply cannot say 12 is less and the 15 is high, so that there's a difference and these students have scored less. You cannot conclude like that because you have not tested. You are comparing, but you are not testing whether the difference between the two numbers, that is 15 and 12, is significantly differing, or is it a random chance? Right? The difference between the 12 and 15, it is only 3 marks, and the deviation in that marks is also 3, average deviation. So because of that, you cannot say there may be students have scored more than 15 marks in that class. So in that case, how can you say this class is the poor performing class? You cannot say like that. Then you have to test. You have to with that all the 60 students data, you have to test with the school average, that is 15. Keeping the school average 15, you have to make the comparison of each of your students with that 15. And there is a process, it's called the t-test. There is a t-test. So if you conduct one sample t-test and make the comparison of all the 60 students with the school average of 15, then if you have a lot of evidences, yes, the difference between the 12 average 12, mean of 12 and mean of 15, the school representative number is 15. So if the evidences are significant, then only you can say this class is poor performing class, then there is a need of additional coaching for that class. So like that you can make the argument, you can give suggestions. Yes, this class is the poor class. For saying the class has scored 12 marks, you need not to have any proof. But for saying the class is a poor performing class, you have to have a lot of evidences. Without evidences, you cannot say the class is poor performing class. Okay, so like that, in any discipline, you have a lot of examples of there is a standard value and you are comparing your situations with that standard, Even in science, you have some standard value when you're doing research in your lab. So I have helped many students in Mysore University to do their PhD as a just supporting them how to make their research more meaningful and scientific, though they are doing in science. Okay, in chemistry, in physics, in biochemistry, I have helped the student. So even in sciences, you have a set standards and you are testing your variables under some conditions, laboratory conditions you are testing. Whether these tested values, you have tested 20 times and you have got some values and you make the 20 recordings or the 20 observations with that standard value. Okay. Just by taking the average, you cannot make the comparison and say this value is less or the high compared to the standard value. Okay, you cannot make that kind of the argument. If you want to say yes, under the laboratory conditions, the observations what have got, it is less compared to the standard value. If you want to prove, then you have to conduct t-test, one sample t-test. Then only you can make this kind of the arguments. So therefore, in each of the research area, there is huge scope for using t-test and making your arguments more reliable and validated. That's very, very important. I'm not going to ordinal data. Let me go to the nominal data. So under the nominal data, as I already told, it is a categorical data, and you have numbers, but these numbers are assigned only for the to make the categories, to classify the data. So classifying like yes, how many yes are there, how many no are there, how many urban students are there, how many rural students are there, how many boys are there, how many girls are there, how many goods are there, how many bads are there. So like that, how many repeated, mode is the most repeated values. Mode is the most repeated value, that is the frequency, So there are two ways of presenting this kind of the data under the descriptive method. So that is, one is it is the relative type of like that percentage. What is the percentage of male participation? For example, even in this course, there are boys, there are women, there are men. How many men are there? How many women are there? Okay, so how many? So that how many can be presented in numbers as well as in percentage. If you present in numbers, so out of 31, just assumes that there are 10 female and 21 male. Okay, 10 female and 21 male. So you can present like that, 10 and 21. 10 female, that is absolute number, that is absolute frequency. If you present the same thing, so there are 30% of female in this course. There's 70% of male in this course. Okay, this is also descriptive statistics. I'm not going beyond that. This is also just descriptive statistics. You are saying there are 30% of female, there are 70% of male. You are saying only that. And you are not arguing the participation of male is more compared to female. No, if you want to say like that, the participation of male is more compared to female. In other words, the participation of arts and commerce is more than science. If you want to say like that, even then you have to have proof. Okay, so simply you can say there are 8 science students, there are 23 arts and commerce students. If you want to say like that, then it's okay. If you want to say the participation of science students is less in this course, then you have to have a lot of proof. And where do you get that proof? You will get that proof here in the chi-square test. You conduct a chi-square test, and calculate the calculated value for the chi-square and make the comparison of that chi-square value with the table value, or using any software you can test whether the opinions are skewed towards male or the female, whether the opinions are skewing towards the science or the arts. So test that, and then you say, yes, there's a less number of participation by the female. There's less number of participation by the science teachers. So like that, you can make the argument. Why less female? Why less science? So are they not satisfied with this course, or is there any other reasons behind that? Why there is a more participation from the management and commerce? So there are a lot of questions behind that. If you want to answer all those, you have to give a lot of proof. So it is also a kind of research. Okay. Then let me go to the next slide. Here I have two variables, bivariate data. Like as I already mentioned, the marks, students' marks, one variable, and the number of hours a student studied. Okay, second variable I am taking. The first variable I have taken the marks. The second variable I am taking, it is the male or female, or even the marks of male and marks of female. Okay, marks of male, marks of female, that I may take. Otherwise, I may take number of hours of studied and the marks of students. So number of hours the student studied, and the marks of the same student obtained. If I have that kind of the data, both are ratio scale data, because we are measuring. Ratio scale, simply you assumes that it is wherever it is possible to measure, it is a ratio scale data. Okay, wherever it is possible to measure. Marks can be measured, and the number of hours studied, it can also be measured. Right? So number of hours, 4 hours he studied, 6 hours he studied, 3.5 hours he studies. 3.5 hours is really less compared to 6, less compared to 4. Like that, you can make the comparison, you can measure. Just by seeing, you can assume that, oh, this is big, this is small, this is large, this is small, this is high, this is low. You get that kind of a feeling. So if you say billion, oh, billion is very big. Million, oh, less than billion. Thousands, hundreds, tens. So for each and every time, we make the magnitude matters. So how to identify ratio scale? A magnitude matters. Wherever the magnitude matters, wherever it is there a possibility of measuring it, so you treat that as a ratio scale data. So number of hours of studied is also a ratio scale. So magnitude matters. How many hours a student has studied? Okay, I have two. If I have two variables under the descriptive, I can compute correlation coefficient. So what is the relationship between number of hours studied, and the marks scored? Is there any relationship between number of hours scored and the marks? Okay, so to know that, I compute correlation coefficient. Some of you may know, and many of you have already did your PhD. The correlation coefficient is always will be between -1 and +1. The lower limit of the correlation coefficient, it is -1, and the upper limit of the correlation coefficient is +1. -1, perfect negative relationship. +1, perfect positive relationship. 0, no relations, null relations. The coefficient sign is negative, but it is not 0, it is not 1, it is in between -1 and 0, meaning there is a relative correlation between the two variables. If it is between +1 and 0, the sign of the coefficient is plus and the value is between 0 and 1. So therefore, there is a positive relative correlations. So that what is the nature of relationship between the two variables? So as you have studied more, whether your marks has increased. As you have studied more, your marks has reduced. Okay, it may be. Sometimes it may be. What you have studied, that also matters, Number of hours you studied, but what you have studied. Have studied the textbook or you studied some other things. Okay, we don't know. So number of hours studied, whether the marks has increased. As the number of hours increases, the marks increases or not. Okay, if it is positive, certainly you will get positive coefficient. Okay, and you will say, for example, you got 0.7. So there is 0.7 degree of relationship. The degree of relationship between marks and between the number of hours studied and the marks is the nature of relationship is positive, and the degree of relationship it is 0.7. So there is 70% relationship between number of hours studied and the marks you have obtained. Can I believe that in all the circumstances there will be a 0.7 degrees of relationship between number of hours studied and the marks obtained? So you have conducted it for some 60-70 students. How can I accept that 0.7? Do you have any proof for that? No, I don't have any proof. Then how can I believe that? If I want to believe, I have to give some proof. Then certainly you have to go for your inferential statistics. So there you have test for the coefficients. Even your correlation coefficient can be tested. Your correlation coefficient can be tested by using t-test. Again, we use t-test to test the correlation coefficient. If the correlation coefficient test, the t-test is significant, meaning if the computed value of the t is higher than the table value, then we reject the null hypothesis. And the null hypothesis is certainly it's equal to 0, correlation is equal to 0. And the alternative hypothesis, it is different from 0. This is how we do. Okay. So if the test has a lot of proof, that is the significance. If the margin of error is less and the confidence of your argument is high, if the calculated t value is greater than the table value, then you say yes, the 0.7 degree of relationship between the number of hours studied and the marks obtained, yes, it is acceptable. So therefore, if you want to say the relationship is significant, you have to provide a tested proof in the form of t-test. So like that, if you have two variables, you can also compute the simple regression. The simple regression meaning you have two variables and you identify one as the dependent variable and another one as the independent variable. So generally, by reading, you will understand that marks is depending on the number of hours studied. Am I right? The number of hours you have studied is not depending upon your marks. The marks is depending upon number of hours you have studied. And then I treat the number of hours you have studied as an independent variable and the marks as a dependent variable. And I run a regression. I run a simple regression by you can manually calculate or you can calculate by using SPSS or you use Strata, Gretel, whatever it may be softwares. So you compute, and even Excel you can run the regression. Excel is a fantastic device. You can use it, make use of it, because there is one software called within the Excel. There is an add-in Excel. There is an add-in Excel. If you go to the add-in Excel, you can directly estimate the regression coefficients. It's not a big thing. It's a simple, very, very simple. Right. So if you go to the Excel and you get some values, that is alpha for beta. So here, the regression is the more powerful technique than the correlations. In the correlations, you explain there is a relationship between number of hours and the marks you have obtained. But apart from that, what is the level of impact, and what is the minimum marks that the students can score. All these things cannot be explained by using correlation. Whereas in regression analysis, you can explain even though the student not studied, what is the minimum marks he could have been scored. That can be explained. And if the student studied, what is 1 unit, 1 hour increase in study? How can it influence the marks? Okay. If a student studied 5 hours, what will be the marks? If a student studied 2 hours, what will be the marks? So all these kind of predictions is possible by using your regression analysis. But how can I believe that regression coefficients? That's again the question. So again, you have to give proof for that. Again, you have to give proof for that. When you give proof in the form of again t-test, again in the t-test, then your regression coefficients are acceptable. Right. So this is how. So the t-test is the most powerful techniques. 1 sample t-test, 2 sample t-test, paired t-test, we have paired t-test, and correlation coefficient t-test, and regression coefficient t-test. So there are many types of t-tests we have. If you know all these things, your research will be better off. Okay. And the right hand side again come down to the 2 nominal variables. Again, I'm not going to the ordinal data due to shortage of time. I am not going. So you have 2 nominal variables. When you have 2 nominals, as I said, a male and female, we have 1 variable. Gender is a 1 variable. And now let me ask some simple questions after this class. At the end of this class, if I ask, are you satisfied with this class? If I ask these questions, the people will say strongly agree, strongly disagree, agree, disagree, no, I don't want to comment. So like that, you will give your opinions, right? Okay. So one variable is gender. Are you male or female? That's one thing, right? The second variable, it's the opinion about the class. And you're giving your opinion at the 5-point Likert scale. Though it is a Likert, so the 5-point scale, not Likert scale, 5-point scale. Okay, it's also kind of the opinion, perception. It is not exactly the quantified value. Strongly agree means what is that number? No. Just assign some number 5. Strongly disagree, I assign some number 1. Okay, like that. Now I have 2 variables. My interest is to know whether the opinion is skewed towards agree or disagree. Is the students or the participants have satisfied with the class or not? That is the one thing. So when I have 2 variables, the first thing I do whether the class has been agreed by the participants or satisfied the students, participants or not. That is the first question. If I get the good results, like most of you have given positive numbers, okay, say yes, right? Most of you have said yes, sir, the class was good, okay. And then out of yes, some of them have also said no, the class was not up to the mark, right? It happens. Some of may not be approved because of we have a heterogeneous group, I know the limitations of the class. Okay, some of them said yes, some of them said no. Now I want to know, first thing, luckily I got more yes, less no. And then out of yes, whether it is more from the male, more from the female. If I want to know, then again I go to the test card, chi-square test. The previous one I have told you, it was the previous one with the univariate, the chi-square test was there. It was the first one, univariate procedure test, what we had, it was goodness of fit test. It was the goodness of fit test. And now it is the association test. Because here we have two nominal variables. When you have two nominal variables, you can do both. You can do goodness of fit test, and as well as you can also use the association test or the independence test. Whether the opinions are depending upon the gender. Is the opinion differs because of the gender or not? So that kind of the questions that we can raise. So here again, though the nominal variables you have, both gender is a nominal and opinion is a nominal, you can do a lot of research work, you can do a lot of tests, you can conduct goodness of fit test, and you can also conduct the association set test. By conducting this test, yes, the class was relatively good, and it was more good for the male compared to the female. The class was good. At the same time, the class was more good for the commerce, economics, management compared to science and literature. The class was good for those who have completed PhD, and it was relatively less good for those who are started research, started their PhD work. So these kind of the multiple kind of the analysis that you can make by using the chi-square test. So this is the two, whenever you have two variables, two nominal variables, two ratio scale variables. And when you have multivariate multivariables, meaning more than two variables. Whenever you have more than two variables, our analysis becomes different and difficult, and it is also more challenging, and it also gives a lot of scope for making the analysis at a higher level. So as your number of variables increases, the power of research becomes more very interesting and more challenging. Always it's more challenging, and you're going to make the analysis at a higher level. So higher level. Therefore, you also know to understand what are all the techniques, tools, and techniques are available if I have more than two variables. If you have more than two variables, and we call it as a multivariate analysis, we call it as MVA, multivariate analysis. Under the multivariate analysis, we have two types of the analysis. One is dependence analysis, and another one is interdependence analysis. Meaning, in the dependence analysis, one of the variable is depending on number of independent variables. For example, demand for a commodity is depending on price of that commodity, income of the customers, taste and preferences of the customers, and many things. Like that, the marks of a student is depending upon number of hours he studied, number of classes he has attended, number of time he spent in the library, hours or number of hours he spent in the library, and many things included, right? So like that, one variable is depending on many independent variables. When you have this kind of the situation, then you go with dependence analysis of dependence. So where one variable or dependent variables to be explained, the predicted by others. So one variable is explained by many independent variables. The dependent variables and independent variables are present. So dependent variable is there, as well as the independent variables are there. So, and we generally use multiple regression analysis like ANOVA, MANOVA, MANCOVA, UNCOVA, UNMANCOVA, canonical correlations. And we also have higher level of econometric analysis, like there are many models like GARCH models, we have co-integration models we have, and then we also have ARIMA models, VAR models we have, and we also have the ARDL models. So there are hundreds of models we have just for the sake of the Example I have given only multiple regression, ANOVA, MANOVA, and all those this. Not even ANOVA, it's MANOVA, it starts with MANOVA. Okay, ANOVA is also there because you can qualitative variable also take into considerations. So under dependency analysis, we have n number of techniques you can use. You can Google it, you can go to YouTube, search for the multivariate techniques, you will get, and you can follow the procedures and you can use it. There is no need of going directly, coming directly Premakumara and asking. You go to YouTube, there are many teachers have freely uploaded the procedure of using this multivariate analysis, you can learn. So there are another kind of the analysis under the multivariate analysis is known as interdependence analysis. So here, no variable thought of as dependent or independent. All are equally important. There are no dependent variables, there are no independent variables. All are equally participating. Okay, all are equally participants. For example, in a team of Kabaddi, there are 7 players. So all are equally important. Catcher is also important, rider is also important, middle person is also important, side covering person is also important. Each and everyone is important. In a cricket team, bowler is important, batsman is important, fielders are important, wicketkeeper is important, captain is important. No one is depending upon others. There is no thought of, oh yes, he is depending upon this. No. But the importance of each is different. No one is not depending on other, but importance of each is different. Okay, there may be a speed bowler. For that pitch, he may be most important. There may be a flat pitch. Some batsman maybe becomes more important. So like that, though there are no independent variable, each of the variable may having a different level of importance. And for handling these kind of the more than 2 variables which are not dependent or independent, all are interdependent, then we can go for cluster analysis, factor analysis, structural equation analysis, and you can also think of higher order of analysis. So nowadays, factor analysis is becoming a most powerful tool, and cluster analysis also becoming the most powerful tool. So you can start off. So this is again the same thing. If you say yes for the are some of the variables dependent on others, if you say yes, then you go for the dependence analysis. If you say no, then you go for the interdependence analysis. A very simple way of thinking. And then at what time I have to stop?
Sir, 11:15.
11:15.
Yeah, what is the time now?
11:09. 11:09.
So it's 11:09. I think I have another 6 minutes to stop.
We'll be having another 5 to 6 minutes.
Yeah, 5 to 6 minutes. So that let me start this hypothesis in the next session, so that it's exclusively getting into another kind of analysis. If you have any doubts or if you want any clarifications or something to add to my talk, please, you are free to.
Sir, it is better to put our questions at the end, sir.
At the end of the
End of the second session, sir.
Second session.
Then shall I continue this?
Yes, sir. Yes, sir.
Yeah. So there are 20 PhD holders here. So that without hypothesis, we cannot proceed in any PhD. We should assume something to, yes, I am going to prove something or going to disprove something. And you also know hypothesis, it's a tentative statement based on some example against the populations. One thing you have to understand in research, whether it may be a science or arts or commerce or management, economics, whatever it may be, even in the literature also, we are doing only research based on the sample. not based on the population. Am I right or not?
Yes, sir. Right, sir.
Yeah. So we are doing research only based on the sample, not based on the populations. When we are doing the research based on the sample, when you got some results, when we draw some inferences, when we make some argument based on the samples, and all these statements, conclusions, or the arguments, or the inferences are applicable to the whole set of populations. Am I right? For example, if you study more, you will get more marks. So this is the argument I made out of the sample of 60 students, but it is applicable to the complete, the whole
class.
Whole class or the whole universe, and the whole education system. When you study more, you will get more marks. So it's universal. That means I am going to universalize my opinion, my argument. When you are going to apply your argument or the statements to a complete population out of the sample, based on the sample, there should be a lot of validation for your argument. Okay. Hypothesis, whatever we conduct, so whatever we have, we need to test that hypothesis before we are making the argument or the statement. Okay. So therefore, first we construct the hypothesis to prove or disprove. And generally we construct two types of the hypothesis, null hypothesis and alternative hypothesis. And let me also make it clear that we are going to test only the null hypothesis, the first hypothesis, H0, not the alternative hypothesis. So alternative hypothesis cannot be tested. It is not possible. Testing alternative hypothesis is not possible. You can test only null hypothesis. So therefore, generally, while testing the hypothesis, we construct two hypotheses. One is null hypothesis, another one is alternative hypothesis. Okay. And your research hypothesis is the alternative hypothesis. You want to prove something. If you want to prove something, you have to have a null hypothesis. If you nullify that null hypothesis, then you can go for the alternative hypothesis. So for the next class, we are going to have this kind of analysis, testing of hypothesis and how do we test. So that comes under the inferential statistics. In the next class, we are going to talk about how to test a hypothesis. So what are the test steps in the hypothesis testing? For that, as a preliminary, so we are testing only the samples. For testing the sample, we have two hypotheses. One is null hypothesis and another is alternative hypothesis. Population cannot be tested. If you want to conduct any hypothesis test, it is only for the sample test. I have given example. Let me tell you one more example of, I have given rice, sambar, 2 plate. Let me take the sambar. Your mother asks you to test the sambar and she gives only 1 teaspoon of sambar, not the complete sambar. Am I right or not?
Sample test.
Sample test. Okay, only testing the sample. And based on that, yes, you are saying, yes, sambar is good.
Sample.
Okay, so you can, if you say tubelets, if a company says the tubelets of my company will burn for 100 hours. So how can you say, I have tested? Have you tested all the tubelets? Is it possible?
No.
If you have tested all the tubelets, burned for 100 hours, what are the tubelets left for sale? So like that, population cannot be tested. It's only the sample we can test. So, and we are testing the sample, and based on the sample, we're drawing the inferences, and all these inferences are being universalized or applicable to the complete set of populations. And if you want to make it universalized, you have to test, and you have to have a lot of confidence one side, and you should not commit any mistakes. Okay, and you should not commit any mistakes. Meaning, while taking the decisions, while making the argument, while making the statement, you have to have a lot of confidence and less amount of error in your decision. So therefore, the margin of error should be less and the confidence should be very high. So in the next class, I will start with what is test, what is type 1 error, and what is the error. Okay, what is the error? And in that way, we have two types. One is type 1 error and type 2 error. So we will start from there. Okay. Thank you.
Okay, sir. Thank you, sir.
At what time-
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Okay.